Hi, my name's Alec Barron, and I'm going to be talking to you about what Competency X came from, which was a concern about how successful our scholars are at transferring their knowledge to new experiences in their internships and their future college work. So, Competency X requires an understanding about what a competency is at Lago Academy. Competency is anything that is graded that shows what you know and what you can do. And it's always based on what you can know and do individually. And we use the metaphor of building a bicycle with our scholars, which is that you have to not only know what all the components do and why they're there, you also have to have the skills to be able to assemble the bike to ride it. So, how do competencies play out in the classroom, the science classroom? In science classes at Del Lago, competencies are an assessment that is graded and shows what you know and what you can do. And examples of evidence for competency include tests, formal lab reports, essays, and interdisciplinary projects. And you hopefully are familiar with what Competency X is. We've decided to take this another levels to make sure that our scholars are more successful with transferring their knowledge to internships. What we are doing is we are designing Competency X to be an assessment system where as our scholars take assessments, do quizzes, tests, do labs, do projects, what they're going to be doing is curating the evidence of their skills and knowledge as being a scientist into a digital portfolio. And once they've accumulated enough evidence, they can earn a digital badge. And then the digital badges, which we'll be teaching you about later, are going to be the currency with which they could possibly earn internships, go deeper in their internships, maybe earn college credit, possibly pass out of certain requirements in their college experiences, and also motivate them and make them more reflective as a learner about what they know and can do as a practicing scientist. So why did we design such an assessment system? Well, first off, there are the macro concerns, and one of which is science major attrition. 40% of science and engineering majors switch to other subjects or drop out. This is very personal for us as science teachers at the high school level because we spend a good amount of our time motivating and getting kids about science and how exciting it is and how many opportunities there are if you're a science or an engineering major. Yet we know on average about 40% of them that enroll as a science or engineering major switch to other subjects or drop out, and that's a big concern for us. They're not continuing to be successful, and there's a lot of research behind why that's the case, and that's part of why we designed our assessment system. Also, there's general college readiness. A number of college students, of course, have to take remedial coursework. I'm actually one of those students. When I entered UCSD, I had to take a remedial chemistry class because I didn't pass the chemistry placement exam at UCSD. And that's a class that's not towards a particular credit degree. Also, there's college completion rate concerns and workforce readiness concerns about creating globally competitive citizens. But for us, the real reason why we designed Competency X, besides these macro concerns, is that we had this learning experience for our scholars called the Dinopocalypse, and they didn't perform so well on it. And it was an indication to us that they may not be as successful as we want on the performance tasks that they have to do in their internships, and then also in their future workforce opportunities or their college experiences. So let me orient you to what the Dinopocalypse is. It's a surprising theory with a real question to answer that we threw at our scholars. It comes from a presentation from Radiolab where they discuss this surprising new theory about how the dinosaurs ended. And the way I learned how the dinosaurs ended is there was a giant asteroid that hit the Yucatan Peninsula, and it was a slow death for all the dinosaurs. It took thousands upon thousands of years for them to die out because of global climate change or something along those lines. But the new theory has been modeled from interesting new data about the impact. And what the new theory is saying is that when the asteroid hit, it ejected so much matter into space that surrounded our planet that when all that matter came back into the planet, it heated up the temperature of the planet to about 700 degrees Fahrenheit. And it got to near pizza oven temperatures, and that would have meant an end to the dinosaurs within hours, not thousands of years. So how does a living organism survive? That's the question that we posed to our scholars, and we wanted them to design an experiment to test out which soils would be more viable for surviving the Dinopocalypse versus others. Well, to do this investigation, you got to know some stuff. You got to know, well, if the planet gets up to pizza oven temperatures, you need to know something about a pizza oven. You need to know something about heat, temperature, and heat capacity. You need to know something about soils and what their properties are like, how water affects soils, and how the minerals within soils affect how they transfer heat. You need to know something about biological molecules and what happens to living organisms when you get up to really high temperatures. How high of a temperature can a living organism survive and for how long? You also need to be able to just design an experiment where you isolate your variables. So there's a lot of knowledge and skill, and then this other category we call dispositions, which is you may not be successful at first, but you're going to have to persist through and try again to be successful in your investigation to get some valid data where you can make some conclusions. So where did Competency X come from? Again, what we're seeing from labs like the Dinopocalypse performance-based assessment and the internships that we had in 11th grade, our scholars were struggling on performance tasks that required transferring skills from one context to another. So when we gave them this investigation, they struggled with isolating their variables, even though they knew that from previous learning experiences. They weren't able to apply their knowledge of heat and heat capacity to be able to design an experiment to collect some reliable data to make a valid conclusion. So what was interesting for us is that it was the transfer of these knowledge and skills that we had been teaching them that they were not successful with to this investigation. We didn't give them a lab handout and say, oh, follow this step, this step, this step. We said, you're the scientist, here's some soil, figure it out, go to your lab bench and design the experiment. So this showed a weakness that we feel exists with science instruction in schools, and it's an overemphasis on the body of knowledge of science. And that's about how things work in the world around us, different physical and biological phenomena. For example, you may walk out of school thinking, oh, I learned about stuff in science, like I learned about plate tectonics, nuclear fusion in stars, DNA replication in cells. Those are things that you know. But what we care most about is that our scholars are able to take that knowledge and conduct scientific inquiry. And they have hopefully built a toolbox of skills and knowledge that they can use to design experiments or conduct investigations to answer real questions, such as asking testable questions, forming hypotheses to guide the design of an experiment, and then, of course, analyzing data and making a valid conclusion from the data that you've collected. So what we fear is that there has been an overemphasis on the body of knowledge of science and not enough emphasis on those the toolbox that we want them to have for carrying out scientific investigations. Our science standards call this toolbox the science and engineering practices, the things you actually do as a scientist or an engineer to answer questions and solve problems for humanity. So our working hypothesis about what was going wrong that led us to develop Competency X is that we felt our scholars did not have enough practice being a scientist to be successful in performance tasks like the Dinopocalypse investigation, and that our scholars were not tracking their skill development. So the combination of not enough practice behaving like a scientist and the lack of tracking skill development is leading to our scholars to struggle in performance tasks that require transfer, taking knowledge about heat capacity, taking knowledge about how to isolate your variables and designing an experiment, and then applying them to design an investigation to answer a real question. And we fear that that's creating difficulty transferring knowledge and skills to biotech internships. And a large chunk, nearly 50% of our scholars do a science-based internship in their 11th grade year, and many of them continue in 12th grade. So what skills, knowledge, and dispositions did we want them to have for the Dinopocalypse investigation? What was it that we wanted them to have but they didn't have, and it led them to struggle designing an experiment to answer the question about what soil would be best to be buried in to survive the Dinopocalypse? We were concerned that they weren't isolating their variables. They weren't accurately keeping records that they could look back on to inform the next iteration of their experiment. They were not collaborating together in the same respect that we in a respect that was useful, sharing ideas and comparing different methods as they were going about this investigation, and then persistence as well. When things didn't work, continue, figure out why it didn't work, and then moving forward and making a change and continuing on. So what we would like you to do is we'd like you to reflect on the things, the skills, the knowledge, and the dispositions that you want your students or new employees to have to be successful in the tasks that you assign them. When they come into your professional context, what is it that you want them, what matters most to you that you want them to have to be successful? These are examples of things that we wanted them to have to be successful with this task of completing the Dinopocalypse investigation. We'd like you to now go and post a reflection on what skills, knowledge, and dispositions you care about most for being successful in your specific work context. Thank you. I look forward to working with you guys soon.